In this video, we're going to graph quadratic functions that are written in what is called vertex form. And remember, vertex form is where we have y is equal to our a value times, in parentheses, x plus h quantity squared, and then plus k out on the outside. And in this particular form, it is called vertex form because we can actually identify the vertex of our quadratic from this particular form. And we can take the opposite value of h, comma, k, and that becomes our vertex of our quadratic. So it's called vertex form because we can take the vertex and pull it out of the equation using our h value, taking the opposite of it, comma, our k value. So we're essentially going to go through the same steps that we went through as we graphed a quadratic written in standard form. We just condensed two steps together because we can do them a lot more quickly now with vertex form. So we're always going to start by determining, does our graph open up or down? This uses our a value here. If a is positive, it opens up. If a is negative, it opens down. Then we're going to find our axis of symmetry and vertex by using our equation here. So we used to have to calculate these. Now we can just pull this key information straight out of the equation. And then, just like before, we're going to put our vertex in the middle of the table, finding points on both sides. We'll then plot the points on the graph, and we will find the remaining key information. So let's jump right in here and get started. The first thing I'm going to do is I'm going to determine if this graph opens up or down. I notice that a is equal to a positive 2. Since it's a positive number, I'm predicting that this graph is going to open upward. So I expect to see this graph look something like a U. Then from here, we can identify a lot of key information directly from this equation. So we can see a is equal to 2, h is equal to a negative 2, and k is equal to a negative 8. Well, what's going to happen here with our vertex is going to move just like h and k move. And as a result, our vertex moves from 0, 0 to the point h is a negative 2, so it becomes a opposite, a positive 2, and k is a negative 8. So this h equals negative 2 tells us our graph is going to move to the right 2, and this tells us, in k being negative 8, that it's going to move down 8. So that's essentially what's happening here. Our vertex goes from 0, 0, and it moves right 2, and it goes down 8, and our vertex point is here at the point 2, negative 8. So we can find all of that key information directly from our equation, which is really nice. We find h is negative 2, k is negative 8, and we can find our vertex is the opposite of h, which is 2, comma k, which is negative 8. Then from here, we know that our axis of symmetry always has to match the x value of our vertex. So without even writing the equation yet, we know that our axis of symmetry is going to be right here because the vertex lies on our axis of symmetry. So I know my axis of symmetry has to be x is equal to 2. So this vertex form has alleviated a lot of the work that we've had to go through to calculate the axis of symmetry and the vertex. Now written in vertex form, we can just calculate those 2 points by looking at the equation. So there's really no calculation involved. We just identify h and k and utilize those values to find our vertex. So here now we're going to put our vertex in the middle of our table because our vertex is the middle of our graph, which makes sense. So it's the middle of our table because it's in the middle of our graph, and we're going to find some points around it. So I'm going to find some points that are lower, find some points that are higher. So we're going to find and calculate what y would be when x is 4, 3, 1, and 0. So now I'm going to go to my equation here, and I'm going to substitute values into my equation for x and find the corresponding y value. So I'm going to start here with x is equal to 4. So I have y is equal to, we have 2 times 4 minus 2 quantity squared minus 8. So I've substituted 4 in for x, and now I need to follow my order of operations. So I'm going to start with the parentheses here. So this becomes 2 times, that becomes 2 squared minus 8. I then follow my order of operations, which is exponent comes next. So I have 2 times 2 squared, which is 4. So that's 2 times 4 minus 8, which then 2 times 4 becomes a 8 minus 8, which I know is 0. So when x is 4, I find that y is equal to 0. And then if I look at x equals 3 next, I'm going to do the same thing. Y is equal to 2 times 3 minus 2 quantity squared minus 8. Okay, so I'm going to do the parentheses first. So I have 2 times 1 squared minus 8. Well, 2 times 1 squared is just 1, so that's 2 times 1 minus 8, which is essentially 2 minus 8, which is a negative 6. And then I'm going to look at x is equal to 1. So I have y is equal to 2 times 1 minus 2 quantity squared minus 8. Parentheses first, so 2 times negative 1 squared minus 8. Then my exponent happens. Well, negative 1 squared is just 1. So we have 2 times 1 minus 8, which is 2 minus 8, which is negative 6. So I see that symmetry happening, which is good. And then here I have y is equal to 2 times my last x value is 0 minus 2 quantity squared minus 8. So that is equal to, we'll do 2 times negative 2 squared minus 8. Negative 2 squared is 4, so it's 2 times 4 minus 8, which is 8 minus 8, which is 0. So I can see that symmetry happening. So now I'm going to plot my remaining points here. So I have 2, negative 8 already plotted. I then have 1, negative 6, 0, 0. I also have 3, negative 6, and 4, 0. So I have a nice quadratic graph there that I can see. Okay, so now that I've got a nice graph here, all I need to do is identify my key information. So I'm going to start with my y-intercept, and that's where I cross the y-axis, which I can see happening right here at the point 0, 0. So I'm going to record that value down as 0, 0. I then look at my x-intercepts, and I notice that there are 2 places where I cross the x-axis, at 0, 0 and at 4, 0. So I'm going to record those as my x-intercept points of 0, 0 and 4, 0. I then notice my graph goes forever to the left and right, so my domain is all real numbers. And my range, the lowest point is negative 8, and it goes up, so I have a range of y is greater than or equal to negative 8. Alright, so let's try another one of these. Let's start again by just looking at our equation here and trying to identify, is our graph going to open up or down? What I notice is that I have an a value here of negative 1. That a value of negative 1, because it is negative, is telling me that my graph is going to open downward. So I expect to see an upside down U for this particular graph. I then need to identify my vertex point. Well, here I notice that h is equal to a positive 2 and k is equal to 1. So I can go and create my vertex point as the opposite of h, which is negative 2, telling me I'm going to move negative 2 in the x direction and a positive 1 in the y direction for k. So remember, my vertex is the opposite of h, which is negative 2, and my k value, which is 1. So I can go over to my graph and I can plot that point. Then from here, I also know that my axis of symmetry has to align with that vertex point. So my axis of symmetry needs to have an x value equal to negative 2. Now that I've got those key items in place, I can move over to my table and place my vertex point, which is in the middle of my graph, in the middle of my table. And I then am going to find some points around it. So I'm going to find some points that go to the left of it, which would be -3 and -4, and some points to the right, like -1 and 0. So now I'm going to go through the process of calculating these points one at a time, just using the order of operations to help me. So here I have y is equal to, going to have x equals 0 here to start. So I have -1, 0 plus 2 squared plus 1. Then I use the order of operations to help me. So I start with parentheses. So I have -1 times 2 squared plus 1. Exponent comes next, so -1 times 4 plus 1. Then just multiplication, so -4 plus 1, which becomes a -3. All right, then I go down to x is -1. So here we have y is equal to -1 times, this becomes -1 plus 2 squared plus 1. We then do order of operations, so it's -1 times 1 squared plus 1. Then comes our exponent, so it's -1 times 1 plus 1, which becomes a -1 plus 1, which is just 0. Then we move on and we do x is -3, so we have y is equal to a -1 times -3 plus 2 squared plus 1. So we start with parentheses, so we have -1 times -1 squared. Well, -1 squared is 1, so we have -1 times 1 plus 1, which becomes -1 plus 1, which is 0. And then lastly, we have y is equal to -1 times -4 plus 2 squared plus 1. Parentheses come first, so we have -2 squared. Then we do the exponent, so we have -1 times 4 plus 1, followed by multiplication, so we have -4 plus 1, which is -3. So now if I take all of these and I actually plot them, so I have -1, 0, and 0, -3, and I then have -3, 0, and 4, -3, I can start to see the nice shape with symmetry of my quadratic graph. Then finally here, my last piece is to find my y-intercepts and my x-intercepts domain and range. My y-intercept is where I cross the y-axis, which is down here at the point x is 0, y is -3. My x-intercepts then occur here at -1, 0, and -3, 0, because that is where I cross the x-axis. My domain goes forever left and right, so we have a domain of all real numbers. And then my range, the highest y value is 1, and then it goes down, so it's y is less than or equal to 1.